Well, hi, good morning. Thanks so much for joining me here in my, it's my laundry room. Yeah, you're looking outside. Summer's coming to an end out there. But here is where I am all the time. In my shop here. And today is September 18th. There's an infamous date. Well, we're going to know by the end of today if the United States is really on the verge of a civil war or just a little bit of kerfuffling is going to go on. Okay, and talking about politics just briefly, hey, there's an election here in Canada in just 2 more days. On Monday we're holding our federal election, and I don't think anybody's making strong predictions as to how it's going to come out, so a lot of silence in that respect. We will see. Should be quite interesting. Usually in Canada the federal election polls close on the west coast, and right afterwards we find out who won. It's that fast, but not this time, because a lot of people are going to be voting by mail, of course, because of the situation, and so the counting might take another extra day or two or something like that, so we might not know till Wednesday or Thursday, especially in a close election as it is expected to be. Hey, in Canada there's basically five parties running. One of them is the Green Party. I'm just going to tuck that one away for a minute, because that's a little hard to fit into what I'm going to show you next. We have basically 4 parties. We have a left wing, a center left, a center right, well, trying to be a center right, and a right wing party. This is a fairly new party. This one's just kind of running its first or second election or whatever. Small numbers of people, but more than expected. So what happens in the Canadian election dynamics is people trade their votes back and forth here on the left, and they trade back and forth here on the right. And the 2 centrist parties are usually the ones who win the election. They're the strongest 2 parties, maybe 3 times, 4 times stronger than these wingers out here. And this one has a long history, by the way. This is the NDP party here. What's happening now is votes that go to these 2 parties get pulled away from these 2 parties, causing the total votes to go to the 2 main competitors to be. That's what goes on in Canada. We have something called strategic voting here too. I've done this. I've done this at times. You look at your own riding. We call them ridings here. R-I-D-I-N-G, like riding a horse. We call them ridings, but they could be called districts or areas in other countries. What you do is you look at the politicians and who's likely to win in your area, and you decide who you want to win or who you don't want to win, and then you pick from the 4 based on the outcome you want to generate, not necessarily the party you want to win. Maybe you're going to vote for a spoiler party to try to knock down the guy who's going to win in place of the party you want. So that's kind of a weird thing. It's called strategic voting, and it does happen here in Canada. Canadians do that. Don't know if that's really a big deal this time around, but there we are. Okay, that's a quick and lousy lesson in Canadian politics. Very lousy lesson. If you're from another country, you have your own dynamics, your own parties, all that kind of stuff. So, okay. What am I going to do today? Today, yeah, I'm going to try to finish this radio today. It's just like every day for the last 3 weeks I've been trying to finish this radio. We're really down to the last steps in aligning it. We're going to follow these steps. I'll put them on the screen in a moment. We'll look more closely at them. I have gone through this once. I did it with video running, but I don't know if I posted the video. The results were I couldn't perform these steps properly, and I think it was, in retrospect, I think it was because the bandpass was too small in the IF, and not enough of the composite signal was coming through for you to develop the stereo stuff. First step here is setting a level from the signal generator that is not too high, and then the next step is to null out any 67.5 kilocycle signal that's leaking through. Then the next step is to tune up the circuits, I believe, that are trying to deal with the 19 kilohertz pilot. And then the last step is to make an adjustment which will improve the stereo separation, provided the 19 kilohertz pilot has come on and all that part of the radio is operating. The current state of the radio is good in mono. Pretty happy with that. My test at the end of the last video to see if a regular station received on an antenna would trigger the pilot, 19 kilohertz pilot, showed that no, there wasn't a single station I can pick up, and there's local FM stations here. There's a station right in Aurelia. Lots of strong enough stations, certainly, to trigger the stereo light. Didn't do it on here. So this is very important. If we want this guy to operate in stereo, then this part has to work. All the readings are done by looking at a meter. We'll use this meter here. And the meter is hooked up, well, actually we may use another meter for one of these tests. When it comes to an audio signal being monitored, we'll use this meter. Now you can see I've got it plugged into the audio record out here as instructed in the instructions, which you'll see. The signal source will be the FM signal simulator back here, RCA simulator, and that's how we're going to do it. That's how we're going to try to do it. I've done this once, and as I say, it didn't work, but I think it was because of the lack of bandwidth in the IF. So let's go through these steps carefully. I want to follow these. There's always little subtle things that I find so easy to overlook. I don't want to do that. And so to that end, I have been studying this list. But let's go through it. Signal generator coupling. Connect composite signal generator, that's what I have here, to antenna terminal through matching pad, as in FM alignment. So the matching pad is this guy here. That's exactly what I got going with my signal generator. So I'm perfect on this. Tuned to the frequency of the generator, but unused by other transmissions. So that's good. The signal generator runs at 100 megahertz, and there's no particular station right there where I am here in Aurelia. What are we looking at? We're looking at an audio VTVM to the record sockets. Now we got to pay a little attention to this on access brackets. So they pluralize this, record sockets. What are they trying to suggest here? That I have to monitor both the left and the right on a VTVM? Because later on down here they specify audio VTVM to right record socket. They could have said that up here. They could have said put it in the right record socket, record socket, and leave it there. They didn't say that up here. They said sockets. I think the reason for that is because you're in the middle of trying to balance the stereo output. And if you, at the start, it's way out of balance, and you plug this into the left, when all the signal is being directed to the right by accident, because the set is not aligned, you're going to have a mess. So I'm beginning to interpret this, and this could be what went wrong for me first time through, because I just hooked up one output. So it's a simple thing for me to have both go to the VTVM. Generator output to 120 millivolts on VTVM, and this is to ensure the output of the generator is at a usable level. Not too high, not too low. My options are a little limited here. I've discovered that my FM signal generator puts out a strong signal, what I believe to be just below the limit of the receiver. I did perform this test. I only used one socket here when I did it. It may have set the generator wrong, but the generator is set at minimum, so I can't get it much lower. My experiments with padding down the output further suggested to me that throwing a little more padding in there, maybe I wasn't doing it technically correctly, led to distortions in the signal in the radio. So I'm really inclined to leave it just the way it is, turn my signal generator to minimum, and a little bit of finger crossing. But you know what, we'll hook both sockets up. I could read one socket than the other on my voltmeter. We can see if there's any difference, in fact. Yeah, we can fool around with this. sort this issue out. But how easy is it to miss the S and not interpret this the way I'm interpreting it now? Easy. Okay, so this is set to level, so it's not overloaded. Now we have to go down to this junction of a transistor and a nearby resistor to make the following adjustment, L203, to try to minimize any signal at 67.5 kilohertz that's getting through the radio. So this is adjusting a trap. The trap is L203. I attempted this last time around. Nothing happened. Could be the 67 wasn't there. I have a 67 setting on my signal generator. I can force 67 kilohertz into the radio, so to speak, or as part, not really into the radio, but as part of the signal that's going in the antenna, and we should be able to do this, but I couldn't do it last time. So it'll be interesting to see what happens when we get there. Then I've got to connect to test point 2. There's a bit of a battle finding where test point 2 was first time around. Then I have to adjust these coils. This one is an L, this one is an L, this one is a transformer. Don't get it wrong, it's easy because there's, I think, a TR204 in there. It's easy to get this, to pick the wrong thing and mess it up. Adjusting for maximum indication, so I believe what you're trying to do is I think you're trying to make the 19 kilohertz come through. Doesn't say look for the stereo light. Nowhere here do they say observe the stereo light. The last step, we put the VTVM on just one channel, the right channel. We just listen to the right channel. We set the generator to send over a left channel signal. We should not hear it in the right channel. So then we adjust to get the least amount coming out of the right channel by adjusting this. And that should top up the channel separation. We're done. It's all about getting that light to come on, and the light comes on when the receiver is beginning to decode the multiplex signal. No light, no stereo. There's another alternative method. We won't even look at it right now. Just if you don't have the kind of equipment I have, you try this other thing. Okay, so first step we're going to do is check the level and check these two record socket things and see what happens. Okay. Now I very thoughtfully turned on my signal generator earlier, so it's all warmed up. Should be all warmed up, ready to go. We're not doing anything with this antenna. Let me get it right out of here. Something about having these big metal rods going through here that unnerves me just a little bit. I gotta find a much better. See what I mean? I need to find a better permanent place for this, for sure, in my shop. Up on the ceiling or something. Okay. We are set. We are set for the first thing. No need to pay attention to the scope. This is on. Whoops. Now it's not. Now it is. Radio on. Here we go. Signal generator is what we're hearing. This guy probably has a bit of a warm-up time too. Okay, so nothing on the meter. Yeah, there is something on the meter. So this meter doesn't really have a zero. This is a decibel meter. So it's kind of a ratio measurement. I believe you can look at it that way. It's giving you a ratio all the time. But it will read directly in voltage. Decibels is a ratio, I think. Remember, anything I say on these videos, Google it and find out if I'm telling the truth. And sometimes when I mean to say left, I say right. Let that be a warning to everybody. Okay, we do have two speakers set up. The other speaker is connected in behind here, in case you're wondering what's going on here. This is for one speaker. The other one is connected in behind and is up to the left here out of view of the camera. Okay, so there is a little bit of a level here. It's supposed to be 120 millivolts. We're only reading, although I got these two plugged in here, only one wire is hooked up. The white wire is hooked up. I'm going to pull out the red one. I'm going to move this over to the other channel. We'll see what happens on the meter. Okay, so that looks exactly the same to me. That's how that looks. So I'm going to turn off the 19 kilohertz. Oh. So I hear a little difference there, but the stereo light is not going on. The 19 kilohertz is very low. That's the stereo coming on. Now that's interesting. Stereo on. So I'm sending over right now a left channel signal. That's interesting. Let's go on the other one here. Okay, and then I'll turn on the stereo again. Left channel signal. Wow, this is a good indication right here that there's channel separation. But the light is not coming on. The light is coming on. Well, okay, so right now the light is on, but it's not in stereo, I don't think. I can't hear it in stereo. Go up a little higher on the 19 kilohertz pilot. And you can hear the stereo come in. So you can turn the light on but not have stereo. Okay, can't rely on the light completely. That's a lesson right there. Okay, so we're going to keep the stereo off by turning that down during this part. Now, where would 120 millivolts be on here? So we're on the 1 volt scale. Volts, thank you. Volts full scale. 1 volt full scale. So that's 1 volt out there. Thank you for writing that there. 1 volt out here. So this number 1 down here, we can't quite see on the camera that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 here would be 0.1. So 0.12 volts is just up a little bit on here. This is a good meter too, it's pretty accurate. So we're in and around the right range. Could I get it up to 120 if I wanted? I'm going to turn up the RF coming into the radio. You know, I'm going to eat my hat here. The RF was turned up. Not making much difference at all, is it? Connected. That's a little surprising to me, but but there are systems in radios to try to keep the volume level. So I'm now sending a mono signal, 75 kilohertz deviation, so normal FM radio signal coming here, mono, and we're still right around 100. I think that's a thumbs up. Okay, I'm satisfied that we've got a safe level coming from the signal generator. Excuse me. Next thing is junction of Q206 emitter and R228. I made this connection once before. So I'm going to stop the video, I'm going to hunt it down and make the connection. I'll show you where it is. This is the circuit board diagram. Transistor we're after is this one, Q206. That's right, junction, I'm double checking, Q206 emitter and resistor 228. You can see right away, there's 228, here's the emitter, and you can see there's a connection right there. This resistor is a little bit on its own right beside this transistor, and there's a electrolytic capacitor I replaced right here. Should be easy to spot this resistor and easy to get on this lead. That's my plan, rather than try to get on this lead, which is a little tricky. We'll see if we can get on this lead here. I just heard the speaker pop. Why would the speaker pop? The speaker's popping because the speaker wire is loose here. As I swung the chassis a little bit, it re-engaged. There's a little bit of... well, I really haven't looked closely at the how the output's done on here. There's got to be a capacitor involved. Okay, never mind that. Let's continue with what we're doing. So, now, can you possibly see this? Yes, you can see it. Good. So this is my landmark I've been using all along. This one transistor here, or transformer. This is the transistor in question. The emitter's back here. The trace comes around to a resistor here, and there's the capacitor I replaced right there. And can we get this on here? There it is. Perfect. Good. Very good. Now, what are we doing with that? We're hooking that up to a voltmeter, but I'm not going to hook it up to the audio. I'm going to hook it up to my usual meter I like to use for these things, which is the another Heathkit. I got a lot of Heathkit equipment in here. Thank you, Heathkit. Wonderful stuff. Really is. Okay, making sure my meter probe is set to DC. Can I just stick it in here? Can I just stick it in here? Is that possible? I don't think so. What about sticking it right in here? My gosh, I can do that. Can I? Maybe I can't. Yeah, it's a little too loose. So I'm going to have to use a clip lead or something dumb like that. That's hanging more and more wire out here, but I'll trust that this won't interfere with the radio itself. I'll have to do a little check on that, I think. Okay, so this clip lead goes to the voltmeter lead. Don't go ground there. Don't go ground there. There's actually some kind of plastic tape in here, in this part. Okay, but that actually a little effort to make it ground. Okay, that won't ground out. Meter's connected. Don't know what I'm looking for here in terms of plus or minus. Voltage L203. Now we gotta figure out. We gotta know for sure. As you get further and further into an alignment, you cannot afford to twiddle the wrong coil, because the moment you do, it's back to square one. So I don't want to make any mistakes now. So 203. Well, let's look for it here. 203. It says right on it 67 kilocycle. 203. So if we use the landmark can, it's on the other side of the board. It's actually sticking out the back of the board. Is that correct? Why am I saying that? Because I see things on the surface are shown in solid lines and things that are on the back are shown dotted. But the big problem with that is these three are not on the back, they're on the same side. Why would they do that? Why would they show these wrong? Even this is in a dotted line. Of course, that's a different kind of dot, slightly smaller dash. This meaning a grounded can and a something like that. Why do they do that? I'm not getting it wrong here, am I? I don't think so. Okay, I just don't want to make a mistake at this point. These coils are coming up. These ones are, I believe, the 19 kilohertz coils or something tied into that. So this is it. This is the trap. 67 kilocycles. Okay, I'm ready. Let's do it. Let's see if we can avoid messing up this radio. Okay, so the meter we're going to be looking at is this one over here. This guy here. Right now it's set to 1.5 volts negative. So a negative voltage will put it upscale. Ground it to the chassis. The chassis is grounded in my shop on a semi-permanent basis with this clip, in case you're wondering what that is. I think we're ready. Oh, now we need to send 67 kilocycles. I got a little dial over here. It's a little hard to see from there, isn't it? Let's go over here. I'll give you the good seat. That leaves me with the bad seat. So we want this guy set to 67. Okay, 67. This meter's now sitting here. That's a little odd there. Why? I'm not sure what this meter is reading when this is at 67. This is normally set somewhere in this range, so I'll leave it there. Top of this, depending upon what the meter's doing here, it could be 67 kilocycles of deviation. What's it say here? This dial does RF deviation, also does sweep width, also does audio level, also does composite signal level, depending upon how you got this thing set. My guess, we're on composite signal level. That's what this is setting. We'll leave it in the middle. I'm not sure where to put it. Okay. We just want some 67 to get into the radio anyway, so I can null it out on the meter. I think that's it. I got this set to audio mono. So I'm hoping it'll still let these high frequencies through. But we can move it around if we want. We can always fool around with this a little bit. So do we get a reading on the meter? That's the first question. Now if this is all set up and aligned properly, the answer is no. The 67 will be trapped out already. We won't even see it. Power on. Whoa! Oh! I wasn't quite expecting that. Okay, 15 volt scale. We've got 9 volts sitting there. Okay, so I know I'm going to do. I'm sorry, I'm going to have to juggle around here because there's only room for so many of us in here. You're taking up space. I'm going to turn off the 67 or turn it to something else. We'll see what gives. So that's 67 again. That's the 38. That's 19. That's 5 kilohertz. You can hear these ones. Oh, first one was 5. This is 1,000. Well, not very reassuring. That's 67. It doesn't say to make it go 0. It says adjust it for minimum. Maybe, and it's probably at the minimum. So I'm going to twiddle that transformer. We'll see what happens to it. It's going to be one slug because this isn't a transformer. This is a this is L203. So it's just one slug. Okay, meter, do you do anything? There's no movement on the meter. Bells are ringing. So the reason to trap out the 67 is so you can't hear the SCA broadcast that this FM station you're listening to may also have going on in their signal. SCA, Subcarrier Administration, I think is what it stands for. But I don't know how many stations utilize that anymore. Probably none, really. So am I worried about something I shouldn't worry about? Yeah, let's just leave it. Whatever it is, we'll just leave it because until Muzak comes out of this radio, I don't think we should worry about it. I can't seem to adjust it. This is the second time I've tried this. I had attributed it to insufficient bandwidth and kind of trapping it out right at the start. But I don't know. That's a little too bad, or should I turn this even further? I don't think so. I just don't have that. I don't have the comforting feeling here that this is working quite right. Indicator junction of Q206. L203, adjust for minimum. Indicator here. It's funny they call it, well, I guess they want to use a very, very vague term here, but it's all voltmeter down here. Let's carry on. Test point 2 is next. So, long story on finding test point 2, I told on another video I probably didn't post. I eventually did find test point 2. Test point 2 has this clip hanging out of it. If anybody's been looking at it going, what the heck is that? That's what that is. That's a clip soldered onto test point 2. And what we do now, this is to try to, I think, so it's adjust for maximum indication. So I left a little bit out of the instructions here. Like when you're adjusting for 67, you need the 67 coming in, but it doesn't say that over here. It doesn't say set your signal generator so 67 is coming through. Here it just says adjust for maximum. Surely to goodness they don't mean the 67. They're just not saying what it is. Test point 2. But not this guy on the output. So I'm going to move my the other VTBM. These are both VTBMs here. Back in 2 voltmeters. I'm going to put the other one on test point 2. Adjust for maximum. Well, at this point, this thing has to be in stereo mode. They don't say that either, do they? Connect composite signal generator to antenna terminal. So I guess that's kind of a roundabout way of saying send in a composite signal. They don't actually say that. Okay, well, I guess, you know, adjust for maximum. Okay, so what I'm going to do, I'm going to flip on the, make sure the stereo light comes on. Stereo light is on now. I'll turn this down so it's kind of on. Kind of in the range where I could hear the stereo separation begin. So conceivably the radio is working in stereo. Look what's happened here. Trouble looking at what's happening here. The meter's gone to 0 here. Right off. It's right down. Well, what all did I do here? Let me turn the volume up just a wee bit. Oh, it's still on 67. That's why. Why do I hear something there? We shouldn't really hear anything there, should we? Yeah. Okay, off of 67. Put it on 1000. Turn the radio down. Now we want to read over here. I've also left this temporary resistor, maybe you can't quite see it, soldered in but hanging out, and the detector circuit I put in is not connected. And the mysterious capacitor over here is still hanging out here, nowhere. I don't know, again, can't remember what I posted and what I didn't. Found this capacitor to be disconnected. I have connected it, and I have subsequently disconnected it. It is in disconnected right now, almost shorting between terminals there. So that's a mystery what that guy's doing. Is that disturbing all this? Don't know. Don't think so, but I don't know. Okay, what do we got on the meter? We got nothing happening on this meter. Let me make it more sensitive now. Okay, so it's gone just a wee bit negative. Positive. Tune these coils 204 and 205 to get 204, 205, and transformer. Wait a minute. No, not this one. This is the one I. No, don't say that. 206, TR 206. I can't read the numbers here. Let's look on the computer again. I can't read the numbers on that page. So these are, so I'm about to do L204, 205, TR 206. L205, L204, TR, this looks like 205, but I think it's 206. 206, this is TR 205, so it's just bang, bang, bang. Any particular order. They are listed as the instructions 04, 05, and 06. Just for maximum indication, doesn't say anything more. Okay, let's adjust the way here. Four. I'm just so hesitant here to make. I don't want to make a mistake. Do not want to twiddle the wrong thing. Okay, so we're going into the first transformer. Is it a transformer? It's a coil. In the slug. There we go. Slug. Oh, heard a change in the sound. This meter is not moving at all. Why? I'm going to remove the connection to the resistor. Just to make, I don't want to have all this stuff hanging out of the radio. Have a close look at this. You know, they're not saying how much to expect. They're not saying what voltage should be there. It's just adjust for maximum. Here we go. It's just no change on it. If I can hear it. No change on it. Okay, let me pull this out of here. Go on to the next one. Okay. Something going wrong. I can hear the changes, but I don't see anything on the meter. So there's something wrong with this test. The last one is this transformer. Yikes. Yikes, 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 yikes. Okay, not behaving. It's not behaving. Okay, what to do now? What do you do when you follow the instructions and things don't work? I'm still in the phase of determining if there's any component problems in the radio. Part of that is doing this alignment and discovering you can't do it because something else is wrong in the radio. Is that where I am now? But I soldered this to the wrong point. The discovering the test point was tricky. The test point is a big involved process to determine it. I'm sure this is correct, but I'm getting no response on the meter. Okay, I'm going to double check that. I'll just do it off camera here. You might as well have a look at this too. So here's test point 2. And you can see it's on a trace with 1, 2, 3, 4 items soldered through on a bit of an angle here, and it's the second piece of trace in from over here, from the corner. It should be very easy to recognize this. And I'm soldered right onto this piece here, I believe. It's this one here. I soldered onto the same as any of these. Why would this not be test point 2? 19 kilohertz written right there. 19 kilohertz written right here. 38 kilohertz written over here. My signal generator has a 38 kilohertz setting. So the 38 is supposed to come from double the 19. So part of the circuit here is to create the 38. I think it's just possible there's a 38 oscillator here, and the 19 is kind of rammed at it, and you get the 38 on target. It locks it in. I don't know if that's the case. I'm just making that up, but I guess there's a possibility this is working in different ways. The stereo light is on. Why don't we just watch that stereo light for a little bit? And I'll twiddle those 3 things again. Okay, the stereo light. Let me stare right at it here. There it is. Now let's just see if I can just sharpen the focus a little bit on that. I'm sure I can. Yeah. I get to see the FM meter too. Now there's no instructions about looking at the FM meter. The FM meter is suggesting this radio isn't tuned. I made no attempt to tune this, have I? Oh my gosh, did I not do... Oh, did I not? Did I not? Okay, so I'm going to vary the RF output on the signal generator, and that's essentially tuning the radio. Let's watch what happens to that FM indicator. Well, I'm tuning. Wow. That's where it sits? There's no signal? Coming back through. Wow, that's... Isn't that... Yeah, that's not the light coming on, that's my hand moving around behind the radio. Isn't that an indication of bad alignment? It won't sit in the middle. There's not a word about it in the manual. That's an interesting thing. So, well, what I'm going to do, I'm going to tune this thing so the light's on. If that's the middle, that's the middle. Now I'm going to turn down the 19 kilohertz pilot. Oops, a little too far. Get a partial light. Pulsing. Now, with the partial light there, I'm going to adjust those coils slightly. Let's see if there's sensitivity. The first two, I've got 19 kilohertz written right on them. Let's see what happens here. Okay, watching the light, the meter, the whole shot. Turning. It's out. Turning back the other way. Oh my. Okay, so I'm going to turn down the 19 kilohertz carrier. Sub-carrier signal, whatever you want to call it. I'm going to turn it some more. Put the voltmeter right on the light and read the voltage going to the light. Why not do that? Maybe that's essentially what I'm doing with that voltmeter. Okay, going to the next coil. Can I darken this at the back here? Okay. Now, here we go. Oh my gosh, look at that. Okay, turning down the level. Oh, a little too far. Back up. Okay, partial light. Tuning. I guess this quiet spot is the sweet spot. Turning it down, it's made it way more sensitive so far. Down, down. It's a hair trigger. There we are. Okay, adjusting. Oop, oop. Circuit takes a moment. Hello. So it's just me moving around is causing effects here. A little bit like a hysteresis sort of thing. There we go. Well, that's about it for that one. I'm going to go back to the first one. And first coil. And we're assuming the light is a really good proxy for look at that. Okay, turning down the 19 kilohertz level. We'll just right on the edge. Clearly, there's no more to get there. Likewise, on the second coil again. Okay, make it a little, turn it down a wee bit further. It's definitely reacting to a much lower 19 kilohertz signal. Okay, turning it up, this way. Oh, it's right there. Okay, we're talking 1 or 2 degrees of turn in there. It went away, but I don't think it's a problem. It's kind of like a hysteresis, or can I just turn it up a little bit? Oh yeah, just a hair there. Good. I think those two are done. I think that's it for those. Next thing is the transformer. It was a transformer. It means it got 2 slugs. Does it have to have 2 slugs? This is the 38K thing. Now, is this past? Maybe this is past the 19 thing that's triggering the light. The light may be triggered by a little tap off of the 19 kilohertz, and then they fiddle with it with a transistor or 2, and the next thing you know, it's turning a light on and off. The 38 may have no bearing on this, so here we go. 38. You can hear the slug jumping. Okay, so I'd say that's having no effect. I hardly turned it though, because I'm a nervous sort of guy doing this stuff. Turn it further the other way. It's going up and down, but I'm not moving at all. I think it's getting brighter. Okay, let me turn this down so it's not quite that low. This is a real hair trigger now. I'm just holding the knob and thinking about it. That's enough to change it. Okay, 38 kilohertz. What? You know what? It's not affecting it. Not affecting it. Put the brakes on. Put the brakes on. I still have the meter hooked up. The meter appears to have gone low while I've been doing this. Okay, so I'm looking at the meter. It's not moving. Okay, so we're unsuccessful at adjusting the 38 kilohertz so far, but you know what I've got? I got a 38 kilohertz signal that'll come from my signal generator. What happens if we throw that in there? Seems to me it shouldn't do anything under this way of connecting things here. Just flip it like this. Yeah, that's my light block there. And we'll go to 38. And what do we got? What do we got? No light. So I'm turning up the 19. Oh, it still comes on. Okay, let's go back. Is it coming on now using the 38? Okay, it could be a little bit of 19 and the 38. I don't know about signal generators that perfect. Okay, so I've set it so it's partially on. I'm still in the 38 transformer. This is a wild shot here. And not affecting the light. So I think we can be pretty sure. If we take a look, let's go on the schematic and just see how that light is wired up so we know more about what exactly we're doing here. Okay, so what we need to find is the light. Now the light will be out on the perimeter here somewhere. Usually they stick them out on the perimeter. The light is going to be related to the light. Show me the light. Well, I don't see it. Let's look. They have the tuning meter showing in here, so I bet you the light is in here somewhere too. Where simply they have a light bulb symbol at the light. Well, it was going to be near those coils I was adjusting. I'm adjusting. Where are they? L204, 19 kilohertz. I'm up in this area here. Where is there a light? 206. Test point 2. By now you've seen the light. That's not a light, is it? What is that? I don't know what that is. I don't think that's a light. If I were drawing this schematic, where would I put the light? I would put it out in this area or down around here. Come on. But if I really wanted to throw people off, I would stick it way down here somewhere. Unexpected. There's that symbol again. The light is a light bulb. It's not an LED. It is a light bulb. Oh my gosh. The idea is to find a light bulb and then just trace the wires back and we'll know how it works. How can they hide this stuff? Headphones. Pilot light. Pilot light. That's close. Oh, look, they just have words. Pilot light. There's no symbol. They've done the same thing then with the other light. Is this the light we're talking about? Pilot light. No, because it's going straight to 4.9 volts just to operate. This must be the on-off light. Okay, so they've probably just written words somewhere. I didn't see any words. Come on. You. Well, maybe there's no light. Maybe that light isn't the light I think it is. Maybe it's some other light. The light is right in here. Right in. They stuck it right inside the circuit here. The light, of course, is on the end of some wires, and I can see the wires. I can see the wires. It's a yellow wire. Where's it going? It's going miles. Yikes. That didn't help much. Lamp. There. Look at that. I just happened to look at it. Lamp. Okay, where? This must be the light. You have 4.9 volts AC coming to the light, and then they're using a transistor to switch the light. What was this other thing over here? It says 47 right there, and that looks like P1, P, pilot light 1. It's a number 47 bulb, so that is the light symbol. That is the light symbol. We have seen the light. Here's the light, and the whole idea is the light is being controlled by this. Oh boy, my transistor knowledge is really rusty here. Yeah, I'm not going to be able to sort this out exactly, but look where test point 2 is. Test point 2, well, it's tied in here, okay, 19, is it 19? Is it triggered by 19? That was the question. So coming out of here, we have 19. Where does 19 become 38? Might have some trouble spotting that. TR206, 38. Somewhere in here, the 38 is developed. I'm just going to take a wild guess that this is a circuit tuned to close to 38. When the 19 shows up, this guy runs at exactly 38. Almost like crystal control. Except it's actually radio station control. It's really what it is. So you sync up with the sending station. So the 19's coming out of here, coming down here, doing something with these guys. The result of that, look like a Darlington thing here, is a signal voltage is sent down here. The voltage, test point 2, couldn't you actually see the 19 here? Couldn't you look at, put a scope on there and see it for what it is? If I'm right about the 38 oscillator here being synchronized by the 19, then this is like a go no-go thing almost. It would have a wide range of acceptable settings as long as there's enough 19 coming at it. That's kind of how it seemed to operate. Well, we have lots of 19 now. I've boosted it by making those adjustments. We should really just turn on a regular radio station and see where we're at. But how am I supposed to know this is tuned right? They said read the voltage here. Never saw the voltage here change. It might be better to scope this than to look at a voltmeter. Yeah, this is, I can't look at this and understand these circuits. If these were tubes, I would understand them just looking at them. But clear, this is all very balanced all through here, all the way up to here. It's all a very balanced looking thing. And how much you want to bet it's left and right channel coming out of there? No, it couldn't be left and, well, I don't know. Could be 38s used to switch one of these transistors or something. I don't know. I don't know exactly. So what are we going to do? That's really the question. So I've done all I can with the lamp. A way to adjust this maybe is by listening in stereo. Okay, so what I'm going to do is I'm going to stop. I'm going to set things up so both I can listen to this in stereo with headphones, and what you will be listening to is the stereo output signal on the video. So you could pop on your headphones and hear exactly the same thing I'm hearing. And we won't rely on the speakers here in the shop. So it'll take me a few minutes to set that up. Okay, so what's going on now is I have the output from the record outs. Just one sec. There we go. Outputs from the record outs heading over to my sound system, pumped right into the video recording sound system. So if you put on headphones, you'll hear exactly what I'm listening to, because I'm listening with headphones too. What's all that gravelly noise there we hear? What? Where's that coming from? It's coming from my microphones. this one in particular. Huh. What's going on there? Why so much noise? From what? Oh, that's terrible. Wow. Oh my gosh. Okay, so I got rid of that. So what I usually have two microphones going in here. I usually have a stereo one, this one up here. I have another one going just off to my left. So when I turn to work on my computer, I'm speaking into a mono microphone, like both channels. Okay, I got rid of that one. Wow, that's terrible. That's just heartbreaking that that kind of noise was there. Boy, have to deal with that afterwards. So now all we're hearing is the output from this radio, and it's pretty quiet because I got all the volumes down. Let me put them up. There we go. Okay, everything we hear other than my voice is coming from the radio. I'm hearing that in my right ear. It's the left channel signal I'm sending, but I'm hearing it in my right ear, so I'm going to reverse these guys here. Watch out for a big hum. No. Wait a second. That didn't work out one bit. Is there something not set to stereo here? I got a bad chord. How did that happen? Let's flip it over to right. Over to the right here. So that should be coming out of the other ear. Once again, can I believe my setup here? What would be wrong? So just so you can see where the signal's going, this cable comes over to this is my sort of like a little bench mixer, if you like. And there's the cable going in. I see the problem. I see the problem. I see the problem. Let's go here. Here. Something definitely wrong here. I know it's on this channel. And yes. Yeah. Those sound effects available all the time, and I never put them on the video. So that's that. This is this. This is this. Why am I getting one channel nothing? Flip these. Something. Oh, what the heck? Something wrong with this cord. Something wrong with this box. Something wrong with what's going on the other mixer. What's wrong? That might have been it right there. Yep. The plug had fallen out the back of this mixer. And you gotta troubleshoot every bloody thing. Everything has to be troubleshot. Yeah, it's my nice little soundboard that I use in here all the time. So, okay, back to where we really want to be. Where do we want to be? Okay, let me balance everything out again. Balanced levels. So, conceivably the levels are balanced now. If you're hearing things out of one ear, it's because the stereo effect is doing it. Let's find out. I'm going to flip the selector button you see in the back there. Left, right, left, right. Well, I don't hear any change at all. The stereo light is on. I'm going to crank up the 19 kilohertz pilot signal. So it's really on. Now we're going to check again. It's all in one ear to me. I don't hear any separation at all. It's even apparent on my volume level meters that one channel is going and the other one isn't. Yeah, absolutely sure now. Let me rotate. Let me flip these and make sure it goes to the other ear. That didn't go to the other ear. Something weird's going on. Why wouldn't that go to the other ear there? Isn't that kind of weird? It's really weird. Turn the volumes up here. Hey. Oh, you know what it is? It's on my, oh, I see it. Okay, so I had the mixer set in such a way that both channels were being driven to the left. That's working. Yeah, you know what? Wow. How many ways are... There's usually like 1 or 2 ways to get things right, and about 42 billion ways to get them wrong. And I'm only partway through the list of wrong ones so far here. Let's put them back in. Oh, one at a time, figure out what's what. I'm hearing that as a mono signal. What the heck? Maybe I'm not. Maybe I'm fooled. This is a mono setting. This is a stereo setting. Yeah, I'm hearing it from one ear. You know what it is? It's the noise. The noise is in both ears, and I guess I triggered on that. So that's one ear. That's the same ear, only a lot louder. So this is, you shouldn't hear anything. Probably this, I'm sending stereo right. If that's so, then I want this to be loud. Yeah, so that's my right ear. Sorry if it's your left ear. Okay, separation's not very good. That's what we're finding out. It's there, but it's not very good. Now I'm going to flip the control back and forth, left and right. Let's hear what happens. Left, right, left, right. So the right one seems to be in the middle. Now I'm going to guess it's that last transformer that needs to be adjusted. So the way they suggest it is you put on one channel and adjust it until you can't hear it. So what we would do is we would put on right channels on right now. Pull it out. You can still hear a little in the left. Now I'm going to adjust to try to get rid of that. And what am I adjusting? I'm adjusting TR something or other. TR 206, I think. Seems like it disappeared to me. Okay, so it's still there in the other channel. Lovely. Now we'll try flipping channel to channel. Beautiful. Still, to my ears, the left is more left than the right. So what if we do the opposite now? So I did the right, we'll do the left. Go like that. We'll kill that one. Still hear a little bit. And adjusting. There's a large sweet spot. I can almost rotate the whole control around. So that's the spot. You don't get 100% stereo separation. Certainly in something of this age. Should be impressed that it works fairly well anyway. So there we are. So now what we're going to do, we're going to tune this radio. Take this out of here. So I still got some stuff hanging out. But we're going to find us a radio station. So I'm going to turn off the signal generator entirely. And I need to hook up the antenna. There's a nice FM hiss there. That sounds great. Bring back the Color Eagle antenna. just to let you know its color, they actually put the colors here. Yeah, I was watching a TV show on space. I watch a lot of things on space and astronomy. And the show was about why are there no green stars? I'm going to turn it down a bit. Oh, you know what? I can't really. I turned it down over here. Right. Because we're listening. We're not listening to the speaker. We're listening here. There are no green stars. And there's no chance of there being a green star. Yeah. It has to do with black body radiation. That was something falling down. That was a camera falling down. Scared the bejesus out of me. Got headphones on, so the sounds are made a little odd. A little odd sound. You ever watch my cats react when there's an odd sound in the house? Boy, they really pick up on it. Same thing we would do, right? What's that? Okay, you can't identify it. Yeah, no green stars. Just red and blue and yellow. Red and blue and kind of in between yellow. There will never be a green star in the world. Okay, so I'm going to turn up the sound level now. We are going to go and tune something in. Oh, I better pull out these rabbit ears have to come out. We are. This is doing absolutely nothing whatsoever. Not connected. This is doing nothing. These are connected straight to the wires at the end of this cable. That's all it is. And that's because it's been rewired. That's not the way it was built. Okay. We go tuning. We're tuning over here. This is the big test. This is to see. This is for all the, what do they say? All the what?
Here's an EC. You get some momentum. Pretty fruitful entry to Victoria Legislature. But then there's several years before the ministry expands. Like, what's going through your head at the time? Are you thinking, maybe God's calling me only?
No, it isn't. No, it isn't. Come on, we're watching for this light. Come on, baby. Give me a station.
Until Black Friday. It's your opportunity to drive home a new Lexus. Book your test drive today.
Come on here.
You got me.
Meter's not quite centered. Stereo light. If we just flicker on a wee bit, it would be fantastic. You can't stop at any of these stations or Mr. Copyright will step in. Not a single one is turning on the light.
The plans have been changed with my XO. Gotta fight for the love with a rush, and I don't wanna let go.
Released me to kind of think about building something bigger than that. And so, you know, last year in particular, 2020, we launched chaplains in Alberta, Regina, and Quebec City.
I believe this is a mono
And
signal.
so yeah, really phenomenal. And
It's a
I mean,
bit of,
honestly,
noise in it, too.
our chaplain team in Quebec City, it's a husband and wife couple. They are just a gift from God to us. I mean, all of our team is, but just finding somebody to serve in Quebec.
It's a religious FM station not far from here.
Potter.
Well, maybe
of houses. It's gonna
do something to get this meter to center properly. Aside from all the things I've done.
here on Crave.
Oh, there it
Sugar
is.
Ray now. Here's Fly on House.
This is telling me I think I got a bad antenna arrangement here. This has happened before. Rabbit ears are directional. So I'm going to move this. I'm going to move this guy out here. Oh my God, what a terrible thing to have in the shop. Okay. It did not get electrocuted. What about out here now? Got the light to come on. That's pretty exciting. This station. I'm gonna get a copyright hit for sure. So if I get a copyright hit, I'll be chopping this video up a little bit. So if you're watching it and it's kind of like all those other video makers who chop out little seconds here and there in their videos, it's because I'm trying to avoid the copyright hit. I have to put it on a station, swing that antenna around. Okay, preparing here to swing. Checking the clearance. There we go.
There's no time to think. Starting off the end. We'll find out, I'm told.
That's the spot. Okay, I got the spot. Standing holding this thing in the air now. Oh, son of a... I'm going to clear my shelves if I'm not careful with this. Maybe I can stick it here. I'm going to go there. Let's see if that'll still work. Fact is, I got the light to come on. Diggity dog, let's try again. So there's a really good chance that if this is back in its regular cabinet with its official antenna connected back to it, because this is coming from a console, that under those circumstances it will, with a more appropriate antenna, it will pick up enough signal to turn the light on and operate. Or alternatively, if I had this somewhere out of my shop, because after all, what's my shop? My shop's a big wall of metal in here. I took it out somewhere and tried it. It's quite a hassle to do that, but so I think I'm going to end it here today. I'm going to ponder the situation a little bit. I may do that, take it out of here and test it somewhere else. Can't really see that I can improve it. It's a little hard to see how I could improve it from here, but not bad. I think I made it all the way through. I think I did. Now I have a record player that goes with this, which I did quite a long time ago. I'll bring that in here tomorrow. That's what we'll do tomorrow. Record player comes in, hooks up to it, check everything out, make sure it's all working. Thumbs up. In the meantime, maybe I can figure out a better FM antenna arrangement. Maybe even using, a folded dipole would be a far better antenna here. I'll experiment around on my own today and see what's up. But thanks a lot for watching. It's been a long, hard journey to get to this point. I feel like, I don't know about you as a viewer, but me as a guy in the shop doing this, it has benefited me personally tremendously to do all this nonsense here. I feel like I know my way in the woods. What a fool. So, okay, see you tomorrow. See you tomorrow. Great.